Welcome back to the fifth part of identities, trigonometric ratios of multiple angle. I'm pretty sure that you may have seen all the parts of identities, that is the part 1, part 2, part 3 and part 4. If you haven't watched, then you have to watch, right? Otherwise it will be very difficult for you to understand. Let's get started. So the you can see question number, that's identity number 22. So in the previous videos, you may have seen 21 identities. Now today's the turn is of 22. 1 minus sine 2 theta over 1 plus sine 2 theta equals to cot theta minus 1 over cot theta plus 1. So you can choose any side, doesn't matter. But the best will be choosing right hand side. Okay. So I'm going to choose here right hand side. Right hand side you have cot theta minus 1 over cot theta plus 1 its whole square, right? If you apply a minus b or a plus b whole square formula, then it will be very difficult to get the real left hand side, isn't it? So the better will be just change cot into cos by sine, right? So I can write here cos theta over sine theta minus 1 over cos theta by sine theta plus 1 its whole square, right? After that I can write here cos theta minus sine theta over sine theta. Down of that we have cos theta plus sine theta over sine theta and its whole square. So we can see we can cut sine theta and sine theta very easily, right? And the next step we have here sine theta cos theta minus sine theta upon cos theta plus sine theta, right? So here we have cos theta minus sine theta whole square, and at the denominator we have cos theta plus sine theta whole square. So let's apply a plus b whole square formula, and a minus b whole square. So we can get here a minus b whole square means a square minus 2 cos theta dot sine theta plus sine square theta, isn't it? A minus b whole square. So at the place of a we have cos theta and at the place of b we have sine theta. Similarly at the denominator as well we write here cos square theta plus 2 cos theta dot sine theta plus sine square theta. Now cos square plus sine square, that's 1, minus and 2 cos theta dot sine theta, that is 2 sine theta dot cos theta, same thing. So we can write here sine 2 theta and over here also cos square plus sine square means 1, and here plus 2 cos theta dot sine theta means sine 2 theta, and you can see that's our left hand side. So we can write here equals to left hand side and proved. Identity number 23. 1 plus tan square pi radian by 4 minus theta over 1 minus tan square pi radian by 4 minus theta equals to cosec 2 theta. Here we have 1 plus tan square at the numerator and 1 minus tan square at the denominator. Can you remember one formula? That's cos 2 theta in the term of tan, right? I'm going to write here. Listen carefully here. Cos 2 theta equals to 1 minus tan square theta over 1 plus tan square theta, isn't it? But here we have plus is at the numerator, but we need minus. What can be done? Look here, if we have b by a and we need a by b, right? So we can do here 1 over a by b. This can do or not? Just reverse, right? Yes, you can do. So here also to get minus sign at the numerator, we have to do 1 upon 1 over. So first of all, we have to choose left hand side. So let's choose left hand side here. Left hand side equals to 1 plus tan square pi radian by 4 minus theta over 1 minus tan square pi radian by 4 minus theta. Sure. Now we need minus sign at the numerator, isn't it? So we can do here 1 over 1 minus tan square and pi radian by 4. Pi radian means 180 degree and 180 degree by 4 means 45 degree. So we can write here 45 degree minus theta over 1 plus tan square 45 degree minus theta. Doesn't matter, you can write pi radian by 4 as well, right? So if you do this, it will be more clear, okay? So it's not compulsory that you have to write 45 degree. So we write here pi radian by 4 equals to 180 degree by 4, that is 45 degree, right? Now 1 over here 1 minus tan square a by 1 plus tan square a means cos 2a. Yes, I have already shown you here. So we can write here cos 2 times a means 45 degree minus theta. This can write. Okay, of course we can write here. Just look here. Now 1 over cos 2 times 45 gives us 90 degree and 2 times theta means 2 theta and 1 over 90 degree minus theta. 90 degree minus theta means sine theta, right? Let's write inside the bracket here. In the formula, we can write the bracket. In the bracket formula, that is, we write here cos 90 degree minus a equals to sine a. Isn't it? Okay. And if you write the formula here also inside the bracket, that will be more clear, okay? So you can write here 1 minus tan square a over 1 plus tan square a equals to cos 2a. Is clear? Okay, now 1 over sine. 1 over sine means cosec. So you can write here cosec 2 theta. So look, what's at the right hand side? Right hand side we have cosec 2 theta. So we got here cosec 2 theta. So finally you can write here equals right hand side, and that is proved. Identity number 24. Sine square pi radian by 4 minus theta equals to 1 by 2 times 1 minus sine 2 theta. We can solve it by two ways. The first by applying the compound angle formula, but the second way is very standard. So I just like to suggest you, yes, you can do this method only that I'm going to show you right now. So first of all, we can write here left hand side. Left hand side equals to sine square pi radian by 4 minus theta, isn't it? Now, so one thing, remember one formula, cos 2 theta in the term of sine, right? Yeah, I'm going to show you here. Cos 2 theta in the term of sine, right? So cos 2 theta equals to 1 minus 2 sine square theta. Can write? Okay, from here, 2 sine square theta equals to 1 minus cos 2 theta. Can write or not? 100% sure we can write, isn't it? But we have only sine square here, isn't it? So from here, sine square theta equals to 1 minus cos 2 theta over 2. So you can write. So we are going to apply this technique here, right? So sine square a means 1 minus cos double of the angle, that is pi radian by 4 minus theta over 2. See here, sine square equals to 1 minus cos 2 theta by 2. So we can write inside the bracket for more clear, isn't it? Sine square theta equals to 1 minus cos double of the angle over 2. That is 1 minus cos 2 theta by 2. Can write? Okay, now next one. Here 1 by 2 we can write like this. 1 minus cos pi by 4. We can write here 2 into pi radian by 4 minus 2 theta. Yes, then we have here 1 by 2, 1 minus cos, it is pi radian by 2 minus 2 theta. Sure. And now that's 1 by 2 and 1 minus cos pi radian by 2. Pi radian by 2 means 90 degree, isn't it? Yes, so it's 90 degree, 90 degree minus a. So we can write here sine 2 theta. Isn't it? Remember, right? Here we have cos 90 degree minus a equals to sine a. According to cast rule, and I have already made the video on the topic of cast rule, right? So if you haven't watched the video, then it's better for you to watch, isn't it? And look at the right hand side, 1 by 2 times 1 minus sine 2 theta. So we can write here equals to right hand side, and that is proved, isn't it? Identity number 25. If tan theta equals to b by a, prove that a cos 2 theta plus b sin 2 theta equals to a, right? So first of all, we have to write here, we have tan theta equals to b by a, isn't it? So we have to prove a cos 2 theta plus b sin 2 theta equals to a. So why not we can take left hand side. So then left hand side we have a cos 2 theta plus b sin 2 theta, isn't it? So after that, let's write the formula of cos 2 theta and sin 2 theta in the term of tan. So we can write here a, and here 1 minus tan square theta over 1 plus tan square theta, and that is plus here 2 tan theta over 1 plus tan square theta. Not to forget that 2 tan theta over 1 minus tan square theta is the formula of tan 2 theta. So we have here sin 2 theta. So this is the right formula. And now, not for, there is a b also here. Okay, there is a b also, isn't it? Yes, there is a b. So better to write the formula inside the bracket. You know, we can write here cos 2 theta equals to 1 minus tan square theta over 1 plus tan square theta, and sin 2 theta equals to 2 tan theta over 1 plus tan square theta, right? So now we can put the value of tan theta, that's b by a. But before that, we can take LCM also. You know, if you take LCM, then it will be more easy, I think, you know. But you can put the value of tan theta also directly, you can put. Okay, so let's put the value of tan theta directly, isn't it? So I'm just going to put the value of tan theta here, right? So we have here a 1 minus b by a, that's whole square, 1 plus b by a, its whole square, there's a plus b, 2 into b by a over 1 plus b by a and its whole square. Yes, just put the value. Now go on simplifying. Here a times, we can write 1 minus b square by a square, here 1 plus b square by a square, here also same, b times 2b by a, and here 1 plus b square over a square. Just simplification, not more than that. Okay, so let's simplify it, and we can write here a times, it's our a square minus b square over a square, and here we have a square plus b square over a square, and like that we have here b times, here we have b times 2b square. Yes, we can write, so 2b into b, we can write 2b square. Of course, we can write here, that's a, and over here a square plus b square, a square at the denominator. Now we see that a square and a square we can cut, right? And here we can also cut. So we can write like this here, that is a times a squared minus b square over a square plus b square. It's correct? Plus, listen carefully. Actually, this should not be b, you know. Just a minute. So we can cut b, you know. Recently we have already multiplied b times 2b equals 2b square, so there won't be b. And after that we write here 2b squared by a over a squared plus b squared. Remember here, I wrote a square as a into a, isn't it? So that we can cut one a and a very easily. And let's write, what's the remaining here. So we write here a times a square minus b squared over a square plus b square, and plus we write here 2ab square over a square plus b square, isn't it? So now I'm just going to take LCM, and LCM will be here a square plus b square only. Then we can write here a cube minus a b square plus 2ab square. Can I write? Sure. After that, a cube and 2ab square minus ab square means plus ab square, and that is a square plus b square. And after that, we can take a from the numerator, isn't it? So a square plus b square, that is a square plus b square, and we can cut it. And lastly, we have equals to a, and just look up, a questions we have that's equal to a. We have to prove that, so we have already proved. That's you can write here equals to right hand side and proved. Today's last question is cos 4 theta plus sin 4 theta equals to 1 by 4 times 3 plus cos 4 theta, right? So we have to choose left hand side. That's left hand side equals to cos 4 theta plus sin 4 theta. Yes, so cos 4, we can write it as cos square theta whole square plus sin square theta whole square. Sure. After that, we can apply a square plus b square formula, isn't it? So that is a plus b whole square minus 2a dot b. Remember, we have cos square at the place of a and sin square at the place of b. And if you write inside the bracket, it will be more clear. So we can write here a square plus b square equals to a plus b whole square minus 2ab. Remember, a square plus b square has two formulae. A minus b whole square plus 2ab, that we are not going to apply here, and a plus b whole square minus 2ab, it's a very important, and generally, we use this formula only. So here you can write a square cos square plus sin square means 1, that is 1 square, and minus here cos square dot sin square means sin square dot cos square, same thing. So we write here 2 outside, and we have the square, so we can write here 2 sin theta dot cos theta over 2 and its whole square. Can we write or not? Remember, 2 and 2 balanced. Sin square cos square we have already here. Yes, can we write? Definitely we can write. Now that is 1 square is 1 minus this 2, and 2 sin theta dot cos theta means sin 2 theta, but remember you have square here also, so we can write here sin square 2 theta, and at the denominator square of 2 is 4. Yes, understood this part? Listen, 2 sin theta dot cos theta means sin 2 theta, but we have already squared, so sin 2 theta whole square means sin square 2 theta, and square of 2 is 4, so we can cut 2 to the 4, right? And remaining part we have here 1 minus and sin square theta, sin square 2 theta over 2, right? But at the right hand side we have cos 4 theta, isn't it? So we are going to remove square, right? Or we are going to change sin square into cos 2 theta. So how to do that? So we can write here 1 minus, and sin square means 1 minus cos double of the angle, right, by 2, and 1 2 is already at the denominator. Look here what I have done here. Just I am going to explain it here. Listen, actually cos 2 theta equals to 1 minus 2 sin square theta, right? Then 2 sin square theta equals to 2 sin square theta equals to 1 minus cos 2 theta, and sine square theta equals to 1 minus cos 2 theta over 2. Remember here. So sine square, here is sine square a, let it say sine square a means 1 minus cos 2a, 2 and a. Remember here, I'm just going to show you, right? This is a and here is a, right? So twice of the angle, twice, so cos 2a, 1 minus cos 2a over 2. So this 2 is already here, and over 2, this 2, is here. I'm pretty sure you may have understood, right? And now after that, you can take 4 is LCM, 2 to the 4. 4 comes here, and now minus 1 and minus plus, it is cos 4 theta. And lastly, we can write here 1 by 4 here, and 4 minus 1 is 3 plus cos 4 theta, right? And 1 by 4 times 3 plus cos 4 theta, which is our right hand side, and that's good. Thank you for watching this video. Similarly, I will be uploading 5 identities in the next episode also. So not to forget to like and share this video. And if you are new, then must subscribe the channel. Why you have to subscribe? Because that will be a kind of motivation, encouragement for us. And not to forget to click the bell icon, okay, to get the new update, right? Thank you. God bless you. Stay healthy.
Tick, boom, here comes the math. No fear, now just clear the path. You want power, you want skills. Join the place where we crush those drills.